Angela, pass it to you.
Awesome. Thanks, Ellen.
Good afternoon, and thank you for joining this webinar on powder coating with LORD Structural Adhesives. My name is Angela Zampanini, and I'm the Northeast Regional Sales Manager for Performance Materials at Parker LORD. I've been with the sign industry for a little over 6 years now, and my favorite part of my job is definitely getting to host training sessions such as this one. Again, I've been in the sign industry for a long time, building my experience there to the point where this year I've qualified for the ISA 2020 Elite class, and I'm also a member of directors for the board of directors at the NSSA Association, which is the Northern States Sign Association. So with that being said, we'll get started. I'll have a chat box up, so feel free to post your questions there in case you're not comfortable or able to ask live. We'll be sure to answer those at the end for you. So let's get started with the harder of the two applications, which is bonding before the powder coat process. These are the general instructions to follow to ensure that you have a good bond before your parts go through the oven. The most important step, and the one that we'll spend most of our time on, is step 3, which is fixturing and building handling strength. Before you select your adhesive, there are a few things that you'll want to consider. The materials you're bonding, the final weight of the bonded assembly, and the details of your bake process will all determine which adhesive you should be looking at. Other things to consider are your desired tack time as well as your UL requirements. Be sure when you talk with us and you're bringing your applications to us that you keep this list handy and that you're referring back to each of these points and you have your answers ready so that we can help you select the proper adhesive. Now, these are the adhesives that you would ideally choose from when you bond before powder coat. We have essentially four different options of adhesives that can go through a powder coat bake process. They all have temperature resistance of up to 400 degrees Fahrenheit or 204 degrees C for up to 90 minutes. So you don't have to worry about the bond line degrading as it goes through the oven. Another great advantage of LORD acrylics is they will come out of the oven stronger than they would just curing at room temperature. And this is a unique property of our technology. And you can see in the slides that we have a tensile strength rating as well as a tensile strength with post-bake. And so that is the difference in the tensile strength both before and after it goes through the powder coat. That is a unique property for LORD technology. MaxLock is by far our top performing adhesive for bonding before powder coat. It has superior temperature resistance, and the tensile strength relative to our other acrylic adhesives is also superior, as you can see in the slides. You'll want to make sure that you use this adhesive if you have large or heavy parts, and if you're using metals such as galvanneal, galvanized, or anything that really has zinc in it. You'll also want to consider the MaxLock adhesive if your oven temperatures are 350 degrees or higher and you have longer bake cycles. The MaxLock, again, it has superior temperature resistance, which makes it ideal for those hotter and longer bake cycles. The 400 series is the next best option, and it will work for most applications. Similar to the 400 series is the SignLock 400 series, which was developed specifically for sign manufacturers. You can use this product if this is a product that you're more comfortable with, but keep in mind that you may want to keep your parts clamped for a little bit longer to ensure that you have enough handling strength before you go through the oven. The last product we'll talk about here is the LORD 810. This is a highly flexible metal bonding adhesive designed to eliminate read-through or the appearance of the adhesive showing up on the back side of, say, a thin gauge panel. We recommend this product for thin gauge substrates and or for Kynar bake process cycles. Step 2 will determine if you're setting yourself up for success or for failure. More often than not, the plungers of your cartridge are not level. As you can see in the picture to the left, this is just a visual to show that the plungers on either side of the cartridge are actually not level. And that's because we fill each side separately at our plant, so they're not always exactly even. The first step in setting up your adhesive is leveling your plungers, which you do by dispensing some of the material without the mix tip on until you see both sides coming out evenly. This will really ensure that the product is on ratio, because if it's not, the adhesive won't cure properly and it could result in poor adhesion. And you can see this before the parts even go through the oven. Now, if you'd like more help with leveling your plungers or loading a cartridge into a dispensing gun, you can check out our YouTube channel for a video on exactly how to do this. Now, you should always make sure to check the ratio of the adhesive before you get started, which is something you can do in two different ways. You can look for color irregularities, as you see in the middle picture here, and that is actually a big no-no. So if you see color irregularities there, it usually is a big indicator that there's something wrong with the adhesive, or your mix ratio is off. Another thing that you can do is dispense some of the adhesive on the side and use a tongue depressor to ensure that it's hardening up. So once those two things are completed, you can dispense your adhesive and mate your parts. Just be careful to note the open time of the product that you selected and the temperature of the environment in which you're assembling. So for Lord adhesives, all of our times in our tech data sheets are rated to room temperature or ambient temperature, which is going to be anywhere between 72 and about 74 degrees Fahrenheit. And our rule of thumb is that for every 20 degrees above the ambient temperature, you're going to cut your open time in half, meaning you're going to have less time to work with the material. Now, if you don't mate your parts in that open time, the adhesive is going to skin over and it's going to result in poor adhesion, if not no adhesion. So that's really important to make sure that you're staying within your open times to ensure that your parts aren't going to come apart, not necessarily just in the oven, but once you have your parts installed in the field. Now, conversely, that works in the opposite direction. So for every 20 degrees below ambient temperature, you're going to want to double your open time as well as double your handling time. And what that means is actually leaving your parts clamped longer so that you're building enough handling strength before you go into the oven. Once your parts are mated, it's important that they don't come apart. If the bond line separates and becomes remated, you can actually entrap air. And air entrapment will certainly cause failures, sometimes as quickly as coming straight out of the oven. In this slide, there's a picture of what air entrapment looks like. You can see splatter marks on top of the squeezed out bead of adhesive. And this is something you don't want to see. This means that there has been air that's been trapped in and the panel has sprung up and squeezed back down. What you want to see is actually just a smooth, even layer of adhesive. So if you do see this air entrapment, what you're going to have to do is completely start from scratch. So that means taking apart your parts, cleaning off the adhesive, and beginning the bonding and assembly process all over again. Now, if you need to reposition your parts, it's best to do this by sliding, not by lifting. Lord acrylic adhesives are equipped with glass beads, which help to enable sliding for repositioning. But if the parts do come apart, or if you simply need to rework the assembly, just scrape off the adhesive, clean with an alcohol wipe, and then start the process again. Once you have your parts laid out the way that you want them, it's time for clamping, or fixturing, as we call step 3. Your parts should be weighted with even pressure until handling strength is reached. You also want to follow one of the 2 recommended paths for proper clamping. You can do this either by starting on one end and working your way down, or you can start in the middle and work your way out, making sure that you maintain about a 4-inch spacing in between each clamp. The path you choose will depend on the size and the shape of your parts, but this is really your preference. What you don't want to do is start on either end and then work your way towards the middle. This could cause the part to bow slightly in areas between the clamps, resulting in poor adhesion in some areas and even stress concentration in other areas. Air also becomes entrapped when your parts bow. So it's important to know that handling strength will vary depending on the size and the weight of your parts. The heavier and bigger the part is, the more handling strength you'll need. A great place to start is our handling time rating and our tech data sheets, which you can download off our website, lord.com. Now, clamps are just one option for fixturing. There are multiple things that you can do to make sure that your parts don't come apart in the oven. You could use more permanent methods like rivets or spot welding. You can also use weights, which are also an option. But if you prefer to clamp, C-clamps, vice grips, and flat end clamps all do a really great job. Now, when you're ready to go through the oven, you want to make sure that you're avoiding bonding parts that are under stress. For example, if parts are formed and they're pressing away from the substrate that you want to mate to, that's going to be, you're going to be bonding stress into that, and it's going to want to already come apart. And then as the adhesive and the bonded assembly goes through the oven, the adhesive is going to soften slightly when it's introduced to that heat. And that softening is going to lower the strength of the adhesive, and the part is likely going to come apart. So making sure that if you do have some formed parts, try and get them as flat and as smooth as possible before you're bonding them so that they don't come apart in the oven. Now that your parts are properly fixtured, it's time to go through the oven. Avoid hanging parts such that you're putting the bond line in shear stress or peel stress, and try to use rolling racks or jigs for particularly large and heavy parts. After the parts come out of the oven, make sure to check your joints for any popped areas or seams. And if you suspect that there was air entrapment, grab a wedge and jam it into the bond line. Put the bond line into peel and just break it apart. That way you can see what the bond line is in between. And we recommend this technique to be used really only on test parts, as these will likely need to be scrapped afterwards. If air does become entrapped, it's best to catch it before the parts go through the oven so you can restart your bonding process and not worry about scrapping your parts. Well, we've gone through the bonding process before powder coat. Now let's go through bonding after your parts have already been painted. This process applies not just to powder coat paint, but to any substrate that's been primed or painted. Here are the general guidelines or instructions to follow for bonding after you go through a powder coat process or bonding right to paint. As you can see, it is fairly similar, especially when you get to mating and fixturing, to the bonding before powder coat process. So the primary difference in the steps comparing bonding after versus bonding before is when you bond after, you really have to make the decision first on whether you want to bond to the metal or if you want to bond to the paint. Bonding to bare metal is really our preferred option because your bond strength is more predictable and oftentimes it's more reliable than bonding to the paint. When you bond to paint, the strength of the assembly is only as strong as your paint. But I don't want to let that scare you. We have been bonding to paint for many years and have thousands of applications and cases that have bonded to paint successfully. So it is doable. You still can do it. The benefit of bonding right to the paint is you get a faster cycle time and reduced labor costs, mostly related to the prepping of the adhesive. You don't have to worry about the extra cost of the masking tape, and you get to save yourself some time in some of the prep by just bonding right to the paint. Once your parts are prepped, mate and fixture your parts using the same guide as for bonding prior to powder coat, ensuring you understand the handling strength you need and are clamping your parts long enough to reach the required handling strength. So for bonding to powder coat, these are your four options. You have MaxLock and 400 series, which from earlier slides you saw that you can use for bonding before powder coat. And these are great options for bonding right to paint. The other great benefit of these two products is you can cross-bond painted substrates to bare metal as well, which is the example of the picture that we opened up for bonding to powder coat. So these are two great options that you can use and keep in-house for bonding both before powder coat as well as bonding afterwards. The next two recommended products that we have are 7542 and 7545. These are urethane-based adhesives and they grip very, very well into paint. And more often than not, these are our first recommendations for bonding to powder coat paint or primed or painted metals. And the big difference between the two is the 7542 has UL 746C approval, and it has a lower viscosity, which makes it great for going into tighter tolerances. The 75-45 is more of a paste consistency. It has a lot higher viscosity. Once your parts are prepped, mate and fixture your parts using the same guide as for bonding prior to powder coat, ensuring that you understand the handling strength you need and are clamping your parts long enough to reach the required handling strength. If you do decide to scuff, make sure you scuff all the way down to the bare metal and follow with an alcohol wipe. And then after that, just mate and fixture as usual. If you'd like more information or you prefer to contact us privately, follow us on social media or visit us at www.lord.com/sign. You can also call our hotline, 1-877-ASK-LORD, to talk with our tech service team.